So today we're starting a new lesson, but it's still about triangles, not super different than what we've been doing. And we're going to be learning about something called the triangle inequality theorem, and then generally trying to see the number of triangles that can be formed given side lengths and angle measures. So the warm-up is quick. It's supposed to be kind of like preparing for the PSSA and just like general good stuff to review. So chapter 1 review, that was on adding and subtracting, multiplying, dividing rational numbers. So it's really when you learn to deal with negative numbers for the first time. Okay, so we have number 1 is negative 3 plus 3. Go ahead, tell me what that is. Negative 3 plus 3. Think it in your head, write it down. Okay, you should get 0. Negative 3 plus 3 is 0. If we need that on a number line, we start at 0, we move to negative 3, and then we move back. Right, we're going negative 3 and then plus 3 and then we get back to 0. Opposite sum to 0 always. All right, now we have 2, negative 4 plus 8. These kind of questions we get wrong a lot. People want to say that's negative 12, which is not correct. Okay, so this is 0. I'll actually put all my spots. Okay, negative 1, negative 2, negative 3, negative 4, 1, 2, 3, 4. So if I start at negative 4, right, that means I'm starting here, right? I could have an arrow to left. I start at negative 4. And then I'm adding 8, which means I move 8 spots to the right from negative 4. So plus 1, 2, 3, 4, 5, 6, 7, 8. When I do that, I end up at 4. All right, so negative 4 plus 8 is positive 4. The rule that we learned, the shortcut, is you can subtract the values. 8 minus 4, that's positive 4. And then you keep the sign of the bigger number, and 8 was bigger and it's positive, so that's why it's positive 4. Okay, and then lastly, negative 6 minus 2. God help me, I hope you know that. Negative 6 minus 2 is negative 8. We all scream it out. You know what to do. The reason that it is negative 8, we're at negative 6 already. And then you move negative 2. You're subtracting 2. You go 2 more to the left. Okay? So that's going to end up being negative 8. All right, so like I mentioned, what we're doing today begins with something called the triangle inequality theorem. The triangle inequality theorem states that the sum of the lengths of any two sides of a triangle is greater than the third side. So you see, this is kind of the expressions we need to have. If I look at this triangle, I have A, B, and C. You can't form a triangle unless when you add up any of the two side lengths, you get one bigger than the third. So here, A plus B, that has to be bigger than C. A plus C has to be bigger than B, and B plus C has to be bigger than A. You're going to explore this concept when you go to Google Classroom, which will be what you do after these notes. So that'll explain it a little bit better for the why. Here's just like a really brief idea of what we're saying. Okay, if this is A, the green one's A, yellow one's blue, and I want to make a triangle, or the yellow one's B, and then I have blue, you could think of it as C. This, as this is formed, this will not form a triangle. You cannot connect. You can't connect those and form a triangle. There's a spot missing. Right, you need the length of this green one and the yellow one. That needs to be bigger than the length of the blue one. Otherwise, there's no space. There's no space to move up and still connect them. So that's kind of the idea. We need a longer one. So you have a longer yellow, like this, then you're able to actually connect them. Right? And in this situation, the length of A plus the length of B is greater than the length of my third one. And that's true for any other combinations. Okay? All right, again, you'll see it more on the computer. But for what this looks like for calculating it, we're going to say, can a triangle be formed with the following side lengths? And sometimes we'll call this like the triangle inequality theorem test, right? some combinations of side lengths will pass the test, which means that when we add up all the sums, we will get greater than the other side. But if any of those, if there's any combination that is not greater than the third side, then it's going to be no. So looking at this, if we have 2 centimeters, 3 centimeters, and 4 centimeters, those are our possible sides of our triangles. We have to ask ourselves, is 2 plus 3 greater than 4? Well, what's 2 plus 3? 5. Is 5 greater than 4? Yes. All right, so that's good. That's what we need. Step number 1. All right, then we have another combination. Is 3 plus 4 greater than 2? Yeah. 3 plus 4 is 7. Is 7 greater than 2? Yes. So we're good. And then is 2 plus 4 greater than 3? Yep. That's 6. Is 6 greater than 3? Yes. Okay, since we have all yeses, yes, a triangle can be formed. These side lengths pass the triangle inequality theorem. All right, now let's look at another one. This one is going to fail the test. So we have 1 centimeter, 7 centimeters, and 8 centimeters as possible side lengths for a triangle. Well, if I have 1 plus 8, that is 9. Is 9 greater than 7? Yeah. Okay, good so far. Then I have 7 plus 8 is greater than 1. 7 plus 8 is 15. Is 15 greater than 1? Yes. Okay, and then finally we have 1 plus 7. That is 8. Is 8 greater than 8? No. 8 is not greater than 8. It's equal to 8, but that doesn't matter. It needs to be It needs to be greater than 8. Okay, so that's all it takes. A triangle cannot be formed. That's going to end up looking similar to this example that I showed you. What will really happen is that situation is, think of this as 1. This is my 1, this is my 7, and this is my 8. If they're equal to each other, you can't form a triangle because a triangle needs there to be some angles involved. It needs to go up. Okay, but if you go up and they're just equal to each other, then they're not going to connect. They're not going to connect. Okay, so no, a triangle cannot be formed. All right, here's a try it for you around this idea. Steve gathers 3 pieces of wood from the scrap pile in the wood shop. One's 3 feet, one's 4 feet, and one is 8 feet. Can Steve make a triangle with these 3 pieces of wood? In other words, do 3 feet, 4 feet, and 8 feet pass the triangle inequality theorem test? All right, I'm going to write the first one to check for you, and then you need to check the other 3. All right, so this is something you can set up on your paper. You don't need to create this chart, but just, to make it clear for the moment. So there's going to be 3 inequalities always that we need to check. Here's one to start with. 4 feet plus 8 feet. That needs to be greater than 3. Okay, 4 plus 8 is 12. Is 12 greater than 3? Yes. Okay, so we're good so far. And now there are 2 others. So write the 2 other combinations. Basically mix around these numbers. And if you get yes for all 3, then your answer is going to be yes. And if you get no for any of them, then your answer is no. So finish that up. All right. So after doing that, the 3 kind of combinations of inequalities is 4 plus 8 is greater than 3, 3 plus 8 is greater than 4, and 3 plus 4 is greater than 8. The first 2 that I wrote, you could have written them in any order, of course, did work out. But for our last one, 3 plus 4 is not greater than 8. 3 plus 4 is 7, and 7 is less than 8. Thus, no, Steve cannot make a triangle. Okay, it fails. No, it fails the triangle inequality theorem. Okay, so what is this actually going to look like? I'm using just cut up crayons. We're saying that's 3 feet in green. That's my 4 feet in yellow. It's my 8 feet in blue. Okay, so if I try to build this triangle, those green and yellow, they can't connect. Okay, they can't connect because 3 plus 4, that doesn't equal 8. So there's no space. They can't connect. They're too small. these need to add up to the side of the third, or we're not going to be able to connect them. We're not going to be able to make a triangle. So that's why this will not work out for Steve. All right, and then the other thing we're doing today is you're given side lengths and angles that could potentially form a triangle, and you have to say, can a triangle be formed? So I spent some time putting together this flowchart for you. This is kind of all the situations possible. It's going to tell you the answer. So I want you to, to try to. I want us to get to a point where we understand this, but I think the first thing when we're doing this is just going to be referring to your flowchart. Okay, so this is a paper you got to keep safe because it'll come up a lot. Okay, so the idea here, we'll start here, is if two sides and a non-included angle are given, then there's more than one unique triangle. All right, so what that would look like is someone gives you two side lengths, and then they give you an angle that's not in the middle of them, and you need to figure out, can you draw more than one triangle? Is that possible? Okay, so we're gonna wait till we actually do examples to like kind of understand this, but that's what's following. Okay, the next one we have is if you're given three angles, how many triangles can we form? So we then have to ask ourselves, do the angles sum up to 180 degrees? Because we know that the sum of angles in a triangle has to be 180 degrees. So if our answer is no, they do not sum to 180 degrees, then no triangles are possible. And if they do equal 180 degrees, then we actually have more than one triangle that's possible, because you could just kind of like take a triangle and scale it and make it bigger or make it smaller, and those would all be different triangles, but they could have the same angles, which we'll see an example of. If you're given three sides of a triangle, which we would call like SSS, you're gonna have to ask yourself, do those sides pass the triangle inequality theorem? So are the sum of any two sides greater than the third? If the answer is yes, then there's only one triangle that can be formed. And if the answer is no, then you can't form any triangles, right, which we just saw. And then the last two situations are if they give you two angles and an included side, which I'm going to call like angle side angle, ASA, or two sides and an included angle, SAS, then you'll only get one possible unique triangle. Okay, so there's only one triangle you can create. All right, so let's look at examples to try to understand that. All right, so now let's look at some examples. So for the first one, I made a mistake. I want this to be 8 centimeters instead of 3, so take a second to change that. Okay, and then this one, for this we have an angle, then a side, then a side. Ha, look at that, funny. So when you have angle side side or side side angle, that's going to be a situation where there are two possible triangles or multiple triangles. So it's just two, but let's talk about why the two is. Okay, so let me draw a 45-degree angle here. Okay, that's going to be 45 degrees. And then next to the 45 degrees has to be 8, a side length of 8. Okay, and then I have a side length of 7 that has to be next to that one. Be here. Okay, and then that's my triangle. That's 45 degrees. That's 8, that's 7, that forms a triangle. But there's actually one other option. It's a kind of weird looking triangle, but there's a different one. So this is 45 degrees. That goes up and it's 8. But then instead of swinging 7 out this way, I can swing it down this way. So that's 7 too. That's still 45 degrees, but then this angle. Clearly those are different triangles. Okay, so that's something that happens when you have side-side angle or angle side-side, right? I mean, honestly, this mnemonic device, looking at what that acronym says, will probably help you remember that's a weird one, right? That's when you have two possible ones. All right, so we'd say there's two possible triangles. And, you know, even if we don't want to go through and draw it, we can look back at our flowchart. And our flowchart says if we have two angles and a non-included side, then we can have more than one unique triangle as possible. So that's going to be multiple as possible. All right, now we have a 60-degree angle, a 40-degree angle, and an 80-degree angle. So that's angle, 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 just as an acronym to help us remember. And our flowchart says if we have angle, 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 three angles are given, we ask ourselves, do the angles sum to 180 degrees? If yes, then more than one unique triangle is possible, and if no, no triangle is possible. Okay, so quickly adding that up, 60 plus 40 plus 80, that is equal to 180 degrees. So that's great. That means yes, we can make triangles, and it's not just that we can make one, we can make more than one. What is the reason for that? It's because the size can change. So these aren't going to be exact, but all of these angles are less than 90 degrees. So I have one that's 80, that's going to be pretty close to 90 degrees, and then one that's 40 and one that's 60. Okay, we'll say 80, 60, 40. Again, it's not perfect, that's not the point. Okay, but I could have it of that size, or I could have it of this size. That's 80, that's 40, that's 60. Okay, those are different triangles. They're way different in size. They have the same angles, and they look. And yeah, those are the same triangles. Those are different triangles. They look similar, and they are similar. That's actually a math term for them, which you'll learn later. But they are similar looking triangles. They're just bigger than the other ones, but they're still different. So we have multiple possible triangles we can make. Okay, then let's look at this one. We have 4 centimeter, 6 centimeter, and 11 centimeter. Those are all sides. So we have side, side, side. Okay, and our rule was for that, what does the flowchart tell us? If we have 3 sides are given, we ask ourselves, do they pass the triangle inequality test? If the answer is no, then no triangles are possible, like we already talked about. And if the answer is yes, then we have one unique triangle as possible. Okay, so let's try to draw that. So again, it's not going to be perfect. I'm not actually drawing it in centimeters, but we can think about sides that are different. So it's 11 centimeters. Okay, so that's long. And then I have, this will be 4 centimeters, and then this could be 6 centimeters. And are those going to touch? Are they going to form a triangle? Well, let's check. Is 4 plus 6 greater than 11? No. 4 plus 6 is 10, and that is less than 11. So that means this fails the triangle inequality test. And as you can see then, right, these won't connect. They have to be less than 11 centimeters. So they're not going to connect. So we have 0. No triangles are formed then. But if they did happen to pass the triangle inequality theorem, we'd only get one possible triangle. All right, then for our last one, we have an angle that's 40 degrees. Then we have a side length of 5 centimeters. And then we have an angle that's 60 degrees. So we can try to draw that. This is 40 degrees. Then I have a side length that's 5. And then I have an angle that's 60 degrees. Okay, at this point, I'll have to connect them to form a triangle. And then I need to ask myself, okay, is there any other way I could have built this triangle? No. I mean, I could twist it around, right? It could be twisted, but it's going to be the same triangle. I have to have this 40 degrees, then this 5, then that 60. that determines that this actually has to be 80 degrees because of the angles. And then, yeah, there's no other way I can make that happen. That's the only way I can form it. And you can try to mess around with it, see if you can come up with a different looking triangle than that, but you're not going to get one. So when we have angle, side, angle, or side, angle, side, there's only one unique triangle, okay? So that's the solution. I don't know how you feel about this. Honestly, this is some of my least favorite math. I'm very bad at picturing geometry, picturing shapes. So this kind of stuff does not come easily to me at all. But some people have a geometry brain, even if they don't feel like they like math that much, because geometry is pretty different than algebra. So if that's the case for you, hopefully you can reason through some of these rules. I tried to help you with the sketches. If not, that's why I created the flowchart, because that's what I would need personally. I just kind of memorize these. There's going to be practice for you to do where you determine if there's one, multiple, or no possible triangle that can be formed. But first, you're going to have the Google Classroom video exploring the triangle inequality theorem.